So let's start with the perfect square binomial or perfect binomial square. Some people say it either way. But let's start by seeing where it came from and sort of where it gets its name. So if you had something that was a binomial, which this is, and it's squared, right, as sort of like 4 squared. So 4 squared is 16, so this is a perfect square, right? If you had done 5 squared, just in case the 4 is kind of confusing, this would be 25. This would be a perfect square as opposed to 50, which has a square in it, but is it a perfect square? All right, so if I take x minus 3 and square it, because it's not a monomial, you cannot just square what's in here and square right there. This is a binomial, so you would have to write it down twice. There's a little formula that you may have memorized in your class that gets you there a little faster, but this is the slow and steady way. And then you would multiply this out using the distributive property or the FOIL method, and you would have x times x is x squared, x times minus 3 is minus 3x. No, right, this times this times this, minus another 3x plus 9. So do you see how we have a square down here and a square here? And this x squared came from squaring the x, and this 9 came from squaring the 3, but you have this term that shows up twice, kind of a doubled up term, that would be missing if you just said, oh, it's x squared plus 9. All right, so this doubled up term is going to be essential. So what happens if you then had x squared minus 6x plus 9, and they said, well, let's factor that, and you would go, oh, look, it's got a square on each end. Okay, so maybe it's a binomial square. So since it's a square, it came from something, you would use the square roots. What's the square root of x squared? X. What's the square root of 9? 3. And this sign right here, the first one that you see in the trinomial, is the sign you're going to bring down. But remember, I just mentioned maybe it's a binomial square because these can trick you, right? You must check these. And the way you check these is you say, assuming, okay, that you got the square root of x squared is x correctly, and the square root of 9 is 3 correctly, and you use this sign right there, assuming this is all good. The check you have to do that's further than that is you go x times minus 3 would be a minus 3x. If I double that, do I get this term right there? Excuse me. And yes, you do. So this checks. So let's try a few. All right, so what if we have x squared minus 8x plus 16? And they say to factor it, and don't forget, you have to look to see if there's anything in common. It saves you much pain. So there's nothing in common, and you go, well, it's got a lead coefficient of a 1, and I could say what multiplies to positive 16 and adds to negative 8. But let's try to use this technique for a little bit longer. So you'd say, well, it does have a square on both ends as well. Let's try that. Maybe it's a binomial square. So the square root of x squared is x. The square root of 16 is 4. This sign is the one you bring down. And you have to check this. So x times minus 4 is minus 4x. If I double it, does it show up right there? Yes, it does. So this is not a maybe. This is correct. And you would box this in and say, move on. But don't forget, you have to check. The first time you don't check is probably when the teacher's going to ask you a question that this is not the answer to. Let's do another one. X squared plus 10x plus 25. Feel free to stop the video anytime you want to, so you can try these, see how you're doing, and then restart it. And don't forget there's practice problems. There's a link to the practice problems in the description so that, you can practice. These actually, I think, are kind of relaxing to do. All right. So let's treat it as a perfect square. If it is, and this is a maybe, the square root of x squared is x. The square root of 25 is 5. You use this sign right here, which is a plus. But you have to check these. x times 5 is 5x. If I double it, does it show up in that middle term? Yes, it does. All right. How about 4x squared minus 28x plus 49? Anything in common? Nope. 4 or 2 won't go into 49, so there's nothing in common. But it does have a square on each end. So maybe it's a binomial square. Square root of 4x squared is 2x. Square root of 49 is 7. You use this sign, and you go 2x times 7 is 14x. If I double it, and actually I guess you could, I often don't check the sign because I'm assuming I've already got it down there right. Minus 14x. If I double it, does it end up being minus 28x? Yes, it does. So this is not a maybe. This is the answer. All right, try this one. Don't forget, does it have anything in common to factor out? All right, and you say, well, 1's any square it wants to be, so maybe it's a binomial square. Square root of 64x squared is 8x. Square root of 1 is 1. I use this sign that's a plus. But we have to check it. 8x times 1 is 8x. When you double it, does it show up in that middle term? No, 16x is not 34x. This is not the factor. Looked good though, didn't it? Actually, it turns out to be 32x plus 1 times 2x plus 1, which is what's called the A times C method, which is in this list. It's like 2 more videos down the road. All right, so you're kind of getting the hang of it. All right, let's do this one a little bit more complicated. All right, so 50x to the fourth minus 160x cubed plus 128x squared, and you're going, yeah, okay. So not what you may have expected to jump from those to here, but it's not too bad. You've got all the skills for this. So I'm looking at it going, well, this is not fun based on my skill set at this particular moment in time. It doesn't have a lead coefficient of a 1. It's a trinomial, so it's not the sum or difference of two cubes. I don't know the A times C method yet. So don't forget, is there anything in common to factor out? Okay, so where you look is you look at the smallest number, which is 50, and either 50 goes into everything or some part of 50 goes into everything. So let's try, I don't know, they're all even. 5 won't go into everything because this is 128. 10 won't go into everything. So let's try 2. And there's at least an x squared in everybody. So let's try 2x squared and see what we have left. So what we would have is 25x squared minus 80x plus 64. And that's doable because this you know how to do now, right? So I'm going to demonstrate for you something that students do that ends up kind of costing them some partial credit points. I want you to see if you can figure out what it is that's going on. Okay, so all right, so let's look at this, and you have 25x squared minus 80x plus 64. Hey, I don't see anything else in common, but it does have a square on each end, so maybe it's a binomial square. And the square root of 25x squared is 5x, and the square root of 64 is 8, and I use this first sign right here. So I'm thinking it's that 5x times 8, negative 8, is negative 40x. If I double that, does it show up here in the middle term? Yes, it does. Okay, ready? What happened? Well, people got so busy doing this part right here, they forgot to bring down this term that they factored out. And if it's a really long process, it's way up there, like maybe 3 or 4 steps. So I strongly suggest that if if you think you could possibly ever do that under the stress of a test, you might want to circle this. Some people and use what I do when I'm demonstrating it on the board. And typically what I'll do is just immediately draw a little arrow down like this, going, don't forget to bring it down. Okay. So, but whatever you do, that's a very common error. People forget. They get so busy, okay, on this really complicated part right there that they forget what they already did. All right, now this next one is actually our last problem. I'm going to show it to you two ways, but I want you to stop and try it and then turn back on the video and see how you did. And this one is 36 x to the fourth y squared plus 144 x cubed y squared plus 144 x squared y squared. And don't ever let a problem intimidate you. If it's being asked to you, it's because you have the skill set to solve it. Okay, so just go, no, I don't care what it looks like. I have my list of rules. We're going to do our list of rules. Okay, and remember the list of rules is attached. Okay, so you can go through and look at those. So stop the video and give it a try. All right, you back? Now there's kind of two ways that I see students do these problems. All right, the one I'm hoping you did, all right, which would cause you less pain, is if you look at it and go, wow, that's kind of busy. Okay, so maybe there's some stuff I can factor out. At least I could get, let's see, everybody has a y squared. Everybody has at least an x squared. So I should be able to factor out an x squared, y squared, and 36. I wonder if I can multiply 36 by something and get 144. Yes, you can. It's 4. So I could think I can factor out a 36x squared y squared, and that would leave me x squared plus 4x plus 4, which is, hey, kind of like that one, right? Now, I don't want to forget this one, so I'm going to draw a little arrow, okay? And I go, maybe this is a binomial square. So square root of x squared is x, square root of 4 is 2. I use this first sign. 2 times x is 2x. If I double it, does it show up here? Yes, it does. So that is that factor. And I need to remember to bring down this common factor that I factored out. Don't forget that. Now, if you didn't say, hey, there's something in common maybe, all right, look at this. It is a square on the front. It is a square on the back. So if you did that, you would go, okay, maybe it's a binomial square. Square root of 36x to the fourth y squared is 6x squared y. Square root of 144x squared y squared is 12xy plus. And if you had boxed this in and left it for your teacher or the computer programming to grade, it would be marked incorrect by the computer, and the teacher would give you probably partial credit because it's not finished. Because do you see how there's terms in common right here? Both of them have a 6 in common. Both of them have an x in common and a y in common. So I'm going to show you how you keep going, because sometimes that happens. Okay, sometimes it happens you're in a rush, or just stuff happens, and you jump for like the fast fix. Okay, and you go, oh, there's a square on each end, and then you look at it and go, oh man. And so I want to show you how to get these factored out, because it's not as straightforward as it seems to be. So in here, we've decided there's a 6xy in common. So that would leave you, excuse me. All right, that would leave you an x here and a 2 here, right? 6x squared y divided by 6xy is x. 12xy divided by 6xy is 2. Okay, so far so good, okay, now this square applies to here and to this term over here. And I know that we were talking about at the beginning about, x minus 3 squared. You cannot do this, right? Because this is a binomial. And pluses and minuses make space. And so see, there's a times right here. So this square applies to here and here. And yes, there's a plus right there, but it's kind of like the word, I don't know, kind of like cannot. Okay, see how there's a word inside of a word? There's several words inside this word. So this is a word inside of a word, like a compound word or something. But this square applies to both of these because of this times. It does not apply to both of these here because of this minus. Plus and minuses make space. Timeses do not. Okay, so this is 6xy squared, x plus 2 squared. So 6xy squared is 36x squared y squared x plus 2 squared. Ah, and it's the same answer. But if you do it this way, you know how every once in a while you hear me in the videos goes, it's going, slow and right is better than fast and wrong. Okay. Sometimes we're going for speed. And if you get right here and hopefully recognize there's something still in common, it's not always as straightforward. So slower and steadier turned out to be much easier. To sit there and stop and go, wait, is there anything in common before I just dive in? Okay. So that anything in common is very important, right? Always ask that first before you start trying to factor any technique, right? And then the next video is factoring by grouping, and then it's A times C method. It has all sorts of names for that method. And see you at the next video.